Welcome to this Digital University session. In this we're going to look at assembly design and looking at some of the updates we've seen since the last version. My name is Chris Morgan. I presented this along with James Sweetlove, but I'm going to be doing the video all by myself today. So in this session we're going to look at some assembly modeling tools, some assembly view tools. We're going to look at the compare model tool that we've now got available. We're going to look at some assembly visualization aids. We're going to have a look at some new tools we have for working with imported data more effectively, and then we'll have a look at the tool for placing decals, logos, etc. So my name's Chris, Principal Design Consultant. I've been at OnePLM for approximately 5.5 years, and I had James Sweetlove present this with me. He's been at OnePLM for approximately 6 years. So during this session, we're going to have a look at the assemble command. Mainly looking at the Flashfit command, seeing how we can use this quicker to put our items together quicker. This is really good for both experienced and new users. And then we're going to have a look at assembly features and weldments. Following on from that, we're going to look at the frame tool. That works very nicely with assembly features and weldments. And then we'll look at the view items, such as section by plane. And then we're going to look at compare models. We're going to look at assembly capture fit, the new auto assemble command, how we can put that into our workflow very simply. Also during assembly, how we can do copy and paste. This is kind of part of capture fit as well, because it auto capture fits temporarily, so those two work hand in hand on themselves. And then we'll have a look at point cloud visualization and visual explode. Again, more visualization tools. CAD direct and internal components, so how we work with that external CAD data, and the decal tool for our labels. So our first thing we're going to have a look at is the assemble command. So when I first started using Solid Edge, I was told assemble, flash fit, you can do a make, planar line, an axial line. Yeah, that's great. But there's lots of other things it can do as well. So looking at the second point on here, allows the part to be assembled to be moved in its degree of freedom. So we can click and hold our left mouse and move it in a degree of freedom, and then we can right click to deselect, select a face to relate, select the other face, and then press and hold again, and we can see that it will then move in the degrees of freedom, less because we've just added an additional relationship. So if we don't click and hold, that's just selecting that face. Right click deselects as well, same as lots of items as well. Also on the right hand side of the screen, you can see we've got the new context toolbar and the little edit definition icon that we know from part. This also starts the assembly stroke flash fit command on there as well. What other things have we got in there? So we've got options to allow, it also does auto floating mates when we do a planar align. So we've got two faces and they won't align because there's another relationship stopping it. It will automatically add a float, where if we do that just as planar align and we don't use flash fit, it will come up and say we can't apply that relationship because it can't apply that zero relationship. We can create parallel and connect if the element types are made locatable. So on the command bar, we can choose the options dialog box, and we can make sure that we have these additional settings in the green box on here, both linear edges, points. I normally just turn all of those on. In previous versions of Solid Edge, having these turned off with improved performance, but as long as you've got a new computer, say normally 3 to 4 years old with the latest version, you won't notice any performance difference turning these on or off. We can also use circular edges for fastness. So think a circular edge is both a circle and it's also flat, because that circular edge is planar. So that allows us to do pretty much a insert command, and we can take advantage of quick pick as well. I do find sometimes when we do that a few times, quick pick will automatically make it so that circle is selected third or fourth time once you've selected that. So if you can't use any of the pattern commands, that's a really useful option. So let's have a look at a little video on this. So those who've done essentials or basic training with me will have seen this video on here. So here we've got this base component on here. Okay, and then what we can do, we can go up to the dialog box in the corner on here, and we can go drawing of active model. So we can go and select an option that's going to take that part or a sub-assembly into our model. We can then use insert component, use the home command. That's looking for where this file is saved. So this is going to my previous location because I haven't saved the file. So if I go and save this into the appropriate location, and then I choose insert component and choose the home command again, this has done this automatically. This is showing the explorer location with these parts. If we're going to bring these parts in, we can select the appropriate faces. If I click and hold, notice I can drag that in the degree of freedom. Right click to deselect, and then select the two faces on here. Notice we've still got our degree of freedom. So for this one, we want to kind of make sure that we're in Flashfit. This time we need to choose the angle command. We can't do this in Flashfit, but we can go and select our two faces and our face for our measurement to lie on, and go and change that, set the angle. I always, whenever I create an angle, is double check that it goes the right way. So for that one, I need to change it from first to second on there to make sure that that goes up on there. Next, we're going to go and grab the axis. So here we've got a simple constraint, but this time we want to select the key point at the center of the circle to the center of the curved circle. So we need to make sure that the points option is on for us to be able to do that. Hover over the edge, choose quick pick and select those two circles, and that is then going to go and make sure that is inserted correctly. And we can also lock the rotation. We can lock that rotation during placement as well on there. So another one on here, we've got the guide, so a simple one to start off with, but need to get, now it makes it much easier being able to drag that as well. So this time we need to go and select the center of the torus. We need to select the center point on here to the axis on there. But again, during this we can't do this, but we can easily go and say, well, actually I want to go and do a connect. This allows a key point to connect to the center point of an axis. This makes sure that this is correct. Next on here, we're going to go and do edit definition, but this time we're going to use construction display to go and show a plane. And then we're going to go and choose our angle command, choose a plane, choose a top face, and then choose the face for the angle to go on. And then we can come out of there, click on the part, have a look at the relationship, and go and set that to the appropriate angle that we want. So next we're going to go back to assemble, and we're going to go to the pointer, select the back face, and then the circular edge on the pointer. Next we're going to go and select this top face, but we haven't got a face to connect to, so we're going to put it to that face, and that's going to automatically do that floating relationship. If we flip that, that is then going to go and flip that pointer with that 3 mil or so dimension that we've got on there. Okay, next we're going to have a look at assembly features and weldments. What and where do we use these? So assembly features, we use them in weldments, predominantly to create weld gap. We use them in assemblies with frames where bolting is required. Where we need several separate parts to have multiple holes or cutouts that update together. You see the image on the right there, you can see I've got a load of slots. These all need to be exact because this is going and fitting two parts together that need to be in exact position. So this frame, if those two parts need to be a different distance apart, it's easier to go and edit this single sketch all in one go. Where we show modification of existing equipment, assembly features are used a lot, so we need to cut that out to go and put that in. That's used a lot in industries such as rail. And then there's other industry and workflow specific uses where people use that, such as somebody might go and create a billet circular and then an assembly feature showing the first machining process and then another machining process and then another machining process, because that certain items might end up going on different machines, so you show the processes that are done on each machine using assembly features. What are and why should I use the assembly features? They're typically sub-assemblies. They consist of the same type of material that are kind of welded together to make a single part. Useful to help create the correct BOM on there. So if we look at the images halfway down on the left, we can see that the green arrow is showing that is showing a weldment. We've got those little orange symbols showing that's a weldment. And then the second image across, sub-assemblies, we can decide whether we're going to show that as a single item or components. That's useful because that drawing can be provided to a fabricator. That may reduce your company's drawing time when provided to that supplier. They then decide exactly how they want to go and make that item, how they go and break it up. We can see how that weldment is indicated. Weldments can also be a mixture of parts, sheet metal, frame elements, and even sub-assemblies. And these will often contain assembly features and weld features. And we can also create parts as well in place on there to represent welds using the features command on there as well. So some do's and don'ts. Don't create planes linked to assembly sketches. Key in a value or key point on a solid. So think about how you're creating that plane to go and put that assembly feature sketch on there. If something changes, that's going to break. It's going to cause you a big headache. So think really carefully about how you do that. Do think about the order of the assembly features. We can't reorder them. It's a request that's been put in years ago. Hopefully that will come in soon, but we can't reorder assembly features at the moment. Do we really need this in assembly feature to represent in the manufacturing process? Is there any reason we can't put this in the part? Does it really need to be at this level? Do you think could copy sketch be a better option? So what we can do is we can create a sketch in the assembly, copy that sketch associatively down into the part, and then use that sketch to go and create those items. That can be a better option in many instances. Don't forget to add the parts you'll cut into the main feature if you use a mirror. So if we cut some holes in one side and we mirror those over to the other side, in the original cut feature, we need to actually, when we get to the select parts step, we need to select the parts that we're going to mirror the cutout into in our next step. Or we could just mirror it within the sketch as well. There's a couple of different options. Think about piers and components. If you've used assembly features, you will have had to turn piers, components, silhouette edges on. So when you're not working with piers, turn them off. If you just constrain the sketch in itself, go and turn the piers off, so you're not constantly trying to create relationships to the underlying geometry on there. Use minimal dimensions or relationships to the assembly. It's less likely to fail if a part changes. Try and constrain the sketch within itself as much as possible, and then just do 2 dimensions or a dimension horizontal, vertical to the other feature on there. If something does go wrong, it's much easier. You're not constraining lots to the underlying geometry on there. Don't try to create assembly features on surfaces. We can't. We can only do it on solids. So try the thicken command, or try and stitch it into a solid to allow us to do that. So let's have a look on here. So the features tab. So on this one, we can do kind of all sorts of features. If we go to the weldment command and mark that as a weldment, that's going to turn to a weldment. A lot of these commands are grayed out until we get to a weldment. So for this, I'm going to do a chamfer command. Choose the setback that I want. I'm doing a chamfer to go and represent some weld prep on here. So notice I've got a 5mm weld prep on there. And then we're also going to do a 3mm weld prep on this edge as well. So that's going to use the chain option to go and weld prep on there. Next, we're going to look at the most simple weld, a fillet weld. So this one, we select 2 faces, and that's going to go and put a fillet along, and that's going to use the shortest edge as the reference as we go on there. We can also choose the stitch command. This needs an existing weld, and it starts with a gap length, and then it goes with a bead length. And then we're going to select the line, and there was a little dot there saying where that start is going to be, so that was where my first 50mm. So next, I'm going to go and choose a groove weld. My screen's actually got perspective on here, so I've just got to go and turn that off quickly. So when we do a groove weld, we select the more complex surface, which is a curved one, and then we select the angled surface, which has got 2 edges, and then it will ask us for the 2 paths, so like the top path of the face and the bottom path of the face on there. That is going to allow it to project that top surface across on that groove weld and show that as a nice weld on there. So next, those are the 2 most common ones, but sometimes neither of those commands will work how we want. So what I'm going to do, I'm going to use a swept protrusion. This is an assembly feature. I've already made the sketch on here, but because I've gone and added and removed, I've just got to go and fix that sketch to make sure everything is associative. And then the sweep command in here is exactly the same as the one that we've got in a normal ordered part sweep. So we select our path, accept, go to our cross section, choose a cross section, making sure that we think about our origin point on there, and then finish, and that is going to go and represent that weld for me on there. Okay, next we're going to have a look at the frame tool. So this is in the tools tab of the assembly environment. So this allows us to create frameworks by running sections along sketches, 3D sketches and model edges, or a line segment. Line segment is now obsolete, but it is still available for you to create within a custom theme. You can use a sample library of parts as the image on the left, or the machinery library, or you can go and create your user created parts, such as the Bosch Rexroth section. So that's a 40mm by 40mm looking at it on the right on there. You also notice in the frame command, top right image, we've got new options that have appeared in the frame, such as the end cap and the gusset plate. I'll show you those in the video on the next slide. So here we've got some components that may have been transferred in to go and create this supporting structure on here, and I've already created the lines on here. So these are all in different kind of locations. So you'll see that these are all 3D sketches on here. So we've got a segment. Some of them are central to the section they're gonna run along, and some of them are kind of above. So what we do, we start the frame command. That will go and allow us to go and choose from our options. So what I'm going to do to make this easier is just use the standard ones, which are in the Solid Edge download folder. So we've got our 80 by 80, select the element that we want, and then click accept. Think about how you would build this up in real life. Build this up section by section. Don't try and do everything at once. and then we can go and edit the cross section, choose a handle point, and say, well, actually that's connected to the top on there. There's a flip option if we had like a C section or something, or a channel, that would go and flip that around by itself. So I'm going to choose frame again. This time I'm going to choose chain, select the 3 elements on there, a slightly smaller cross section on here, go into my options and change the corner treatment on here. So I want to change that corner treatment so we've got butt ends instead. And then with the edit cross section, this is going to do all of those at the same time. So by me selecting the appropriate option on there, we can also see in the options as well, we've got our coping on there. So if I turn the coping option off, we've now got rid of that coping. So that's kind of given us our weld prep automatically. Next, I want to do these sections. Notice I'm building these up slowly. I'm not doing those others because I want those to cope to the other ones. So I'm going to go and choose my appropriate options. I've got my 80 verticals, I've got my 50s on there, but we can see that's coming through on there. So we need to kind of trim these to certain surfaces. So what I need to do is click the endpoints of those, choose my extend trim, choose what I'm going to do. So I'm going to do the face on here. And I'm also going to go and choose the plane in between so they trim to each other. Notice I'm selecting that plane in the center, and that's going to go and trim all of those sections nicely for me on there. Next, we're going to have a look at frame end caps. So we've got a couple of different options on here. So we're going to do this based on the frame cross section. We can use save settings on here to make life much easier. So once we've spent our time developing what sizes we want, we can easily go and create those using that option on there. Next, we're going to look at the gusset plates. So gusset plates are created one at a time. Again, try and use save settings as much as possible. So here I've got a 50 by 50, 8mm thick, and this is centered. And on this we select 2 surfaces. We can only create one at a time. And then here we've got our placement, so we need to make sure that's centered. Currently that's offset, so I want to just set that to 0, and that is then going to go and place that. I'm just going to speed through and create the rest of these. Once we've done one, it's very easy to create the others. Notice we can also create it within the part itself. So this is a single sheet metal part, and then this one we want to go and do a 4mm offset, select to the right, and we can go and create that gusset as well. And then let's easily go and create the rest of those gussets. Just click direction, click direction, accept. So if you're used to using your right mouse button in Solid Edge, and there we go, we've got our finished item, maybe a few holes and chamfers and stuff to be added, but that's good. Okay, so next we're going to look at compare models. So this is a tool that we have within Solid Edge. Depending on what you've got open or closed, you might not see it, so I would think about closing everything down and then go to the appropriate menu. So visualizes the difference, also shows the difference of the properties, takes away the guesswork if we've got revisions of a part and we don't know exactly what has been changed. Somebody's revised from revision C to D, etc. So removes room for error, and there's also a drawing equivalent which has been around since ST8, which is a long time ago. I remember that coming out. So let's have a look at this. So we've got no models open. If we go to File, Tools, we've got our Compare Models option. So now that's opened, we can go and choose our reference and then our working model. So on this we're going to go and choose my bracket mount, and then I'm going to choose my revision 2 of that same model on there. So we can decide what colours these are going to be, what kind of changes we want, any other changes, and then we can choose the compare option. That's then going to go and compare the model against the other one, doing like a Boolean option in there. And then we've got a nice preview, and we can see the colours. So we've got the blue for the added, the white for the removed, and then anything that's changed position would be red, we can't see, and then the common is the green colour on there. So we can spin around and see that live. So we can see we've got some little chamfers that have been added, and we can go and turn those on and off. So if there's certain areas we're not interested in, we can easily go and say, yep, I'm not interested in looking at that. Let's go and turn that back on. So we can see those little chamfers that are in those little rounds and chamfers. And we can see the difference in the original models on there. We can also generate a report. We've got different options, and we can choose where we're going to go and save that to. So for this one, we're going to save that as compare model report as a HTML file, and then we can open that after saving. We do have other options: 3D, PDF, Word. HTML tends to be the smallest file, and then we can go and open that up, and we can see on here in the yellow we can see we've got the differences between those options. So everything else is the same. Yellow is showing the difference, so we can see we've got the mass on there, center of volume position has changed, the moment of inertia, principal axis, and radii of gyration has all changed, and it will give some images using those base views as well, showing where those are. Thank you very much. So next is section by plane. So this is a simplified section creation tool. So rather than having to go and draw on a plane, offset it, draw a sketch, allows us to use just a straight plane. Simple cuts that are created using these planes can be moved and rotated using a steering wheel style device. So if we've done synchronous, we may have used that in the assembly environment. That's also available here. The side to remove from the cut can be specified with a simple cut using the flip button or the F key on the keyboard. We can add up to 3 planes. See on the right hand image we've got the add cutting plane option that allows us to go and add another plane. You can use the X, Y and Z keys to define the planes. When we start the command, the Z key, the Z plane, which is like the flat, the base, the top plane, whatever we want to call it, in front of us is the default plane when we use that. This is found on the PMI tab. I would recommend that you right click this, add to quick access toolbar, so it appears on the top of the screen, so we can do this from the home screen, just makes life a little bit easier. So on here, this is the default setting, PMI, and then we've got section by plane there. Notice that's our top plane that is matching, and we can go and choose the steering wheel. At any point we can select the Z key to go and put that back to the default setting. If we press the Y key, we go to that orientation, Z back to the bottom, and then X to there. At any point we can use that flip key, or we can use the arrow to go and decide what kind of direction we want on there. We can also decide what colour this section is going to be. This is only for viewing while we're creating the plane. Once we create the plane, this goes to the actual model colours on there. So we can just use one of the keys to go and reset that, and that's what the flip option is going to do on there. So if we go and add another plane, notice that is creating that to the X, and we can choose to go and add the additional plane. What this is doing is actually taking everything away. If we go and choose O or the bounded option here, this is going to go and flip those, which is kind of the output that we want. We can go and choose plane 1, 2, 3 and adjust those as we need to. And then we can choose what we want to cut. So we can choose cut all parts, only selected parts, or only unselected parts on here. So if we choose selected parts, it turns off temporarily. This then allows me to go and click on the parts that I want, right click to accept, and then do a preview and finish. We've also got the option for deciding whether we're going to cut hardware parts or not. So if we go and create a similar section to what we did before, let's just go and create these nice and quickly on here. But this time we've got a certain component, such as this cut hardware. So what we've done, the motor, we've actually defined this as hardware. So even though I have gone and selected on there, the motor has been defined as a hardware part. So let's go into that motor and have a look and see where we go and define that. So if we go to our file properties on there, and we scroll down 4th from the bottom in this section, we can see hardware, so we can do that yes or no. So if we go and change that, that will then go and apply the cutout on there. We also have the option on here, section by planes with associative planes. So if you want to associate it to a surface, existing plane, doing those, there is the additional option on here down the bottom. So once we click associative planes, the add, delete, etc. all grey out, and we can do that with our traditional plane placement that we would use within our part modelling command. Okay, next is assembly capture fit. So this is now available without having to assemble parts. It's available in the part and assembly environment on the tools tab. So we can see where this is found on the tools tab, in with requirements, component structure editor on here. When we start this, we go and create assembly groups, add relationships. That means when we bring this into a part, we're going to get the auto assemble command start automatically. We'll see that in the video now. So we've got assign capture fit in here. So what we need to do is think about what we're assigning capture fit to. So this is the spotlight that we want to go and place. So we're going to go and do a sign capture fit. We can create groups here, but we don't actually need that extra group. So I'm just going to go into that group. I'll remove the second one in a minute, but I'm going to call that spotlight. It's very important that we get that exactly right, so no space, capital S, capital L, and then we go and create the relationships that we want. So on here, I'm going to make sure the relationships are all exactly the same. So my first relationship is going to be a mate to that face, and then I'll do axial line to the front left, axial line to the front right on there, and that is my relationships that I've got on there. I can then close that dialog box, save that assembly, and then close it or leave it open. These brackets are what we want to go and snap to. So if I go and edit into this bracket and then go to the Tools tab and go to my Sign Capture Fit on here, so that's going to go and allow me to go and rename this relationship group. So spotlight, no gap, capital S, capital L, making sure that is exactly the same. And now I'm going to do a mate relationship, and then I'm going to do a axial line on those two faces. I'm going to make sure that we close that dialog box and make sure we save the part. There is no save on that dialog box. It saves as soon as you go and add the relationships on there. We can see the 8 holes on the bottom of this sub-assembly. So I'm going to open this sub-assembly in a new window. I could put this in the sheet metal part that's down a couple of levels, or I can go and put it in the sub-assembly. It doesn't matter which one we do this in. We do need to be careful not to do it in both, otherwise we might end up with the spotlight going in there twice, both linked to the sub-assembly and to that one. So again, we're going to do spotlight, press enter, mate is automatically defined. So we can go and choose our appropriate relationships, just showing you kind of exactly where these are on here. And then we can go and select those two faces. Also got this the same on here, so rather than closing it, we're going to go and create this again on the other side. So I'm going to call this group exactly the same because we want that same light, spotlight, to come in exactly the same location on here. So once we've done the spotlight, we can go and add our relationships. It's on axial, so let's go change that back to mate. Select the mate, change that back to axial, select the front left and the front right, and just double check that all matches on there. So let's close that dialog box, save this and close, and then let's get back to the original assembly and we'll show what this works like now. So everything's ready. So if we go to our insert component, and then we can go and find our spotlight. So we're actually using an assembly here. There is a part version, but I've changed it so it's a little bit more different. And notice this is coming up with assembly mode, automatic, and it's kind of picking up targets. There's one on there that it's not picking up, but if we click identify targets, that's going to go and find all of those locations for me. We can toggle the component selection if we don't want one of those. So if we click that, all we do is click on the component itself, not the dot. So just click on the component and that's going to go and turn those selections off. So if we don't want spotlights for this version, let's go and just pop those back on. And that's going to go and place those, and it's going to go and place all those relationships. So I think we've got 3 relationships, 6 of those. We've placed 6 parts, 18 relationships, all in one go. Next, we're going to look at assemble, copy, paste, and assemble multiple sub-assemblies. This allows us to copy, paste, and assemble multiple sub-assemblies in the same file, or we can copy these and take these into a different file altogether. This retains the internal relationships. So on this image, the green highlighted, you can see there's 4 screws on each of those sheet metal components, and there's also a sub-assembly. There's a little bearing on the top, which is actually a sub-assembly, so it retains all those relationships within those parts on those. Individual occurrences of parts from the sub-assemblies can also be copied and pasted as well, so we don't need to choose them from what we class as the active level. Sub-assemblies can be copied and pasted with parts. We'll see that in the video in a minute. Okay, so here we're doing it within the part itself. We've also got another assembly we want to go and copy it from. So it's important that we get our selection correct. If I go and select on there, I'm kind of selecting sub-assemblies and parts, and if I go and copy and paste, I don't know exactly. We can see 1805 wasn't kind of highlighted properly, but we've probably got the parts selected in there. So what I'm going to do is just deselect that and reselect that and make sure that I've got all of the correct components on there. I'm going to copy. I could do Control-C or use the copy command. I'll just show how we can do that. And that's then going to bring up this new dialog box, copy and paste. In this dialog box, it's very important that we make sure this top left external relationships is on. Sometimes this turns off, so it means that we're not redefining the internal relationships within those parts that we're pasting in. We want the internal relationships to stay as they are. And we can also see there's actually faces highlighted on here, so we can see that this is asking for certain relationships. We can see we've got our axial line. We've already done the face, so the axial line, well, this one it's upside down, so we need to select this far one, and then the next one is the one on the other side. Kind of makes sense. Once we've done it a couple of times, it becomes easier because we know where this is going. So next we've got the internal face on there. Again, this needs to be on this side, so we need to select that face. Let's zoom in, have a look, see what the next face is on there. You can see we've got that edge, so it's going to be the back face on here. And then the next one is going to be the top face on there because I know what we're doing. And now we've got our sub-assembly, this FM500 1805. That's the top face, and these two edges on there as well. So it's saying there's some relationships unresolved. That means that I've probably copied all those parts again because I didn't quite get my selection right at the start. So it's really important that we do get that selection right. I've done it wrong on this instance. I will do it correctly next time. So let's just get rid of that one from the list on there. So what we need to do now is go and copy some of these over to the other one. So I want those four, I want that, but this time I'm going to select 1805 directly from there. These are the parts that I want to copy, and then I want to copy them over to this larger version of this, but I want to copy them to the sub-assembly. So I'm just going to go and open in new window this 1560 sub-assembly. You can see that we've got the components on the bottom. We've already pasted these ones, so our life is going to be much easier. We know that we're checking our external relationships, we know the faces that we're doing. Not quite sure which one we're doing. We're doing this one on the top, so let's go top, edge, edge. It's now exceeding large assembly. I'm going to leave that out, and then we're going to go and paste this again on the other side. We know what we're doing, so it's check external relationships every time. I've been caught out a couple of times, so, and then we can go and paste hole and hole, and we've got that all in situ very quickly, pretty much 20 seconds. If we dragged all those parts in, put those screws in, life will be much more difficult. And we can see that's our assembly, all nicely red, all nice and finished on there. Okay, next we're looking at point cloud visualization. So this gives us the capability to insert point cloud scans into data. These point cloud data are typically generated by laser scanners. It can be used for brownfield installations. I've seen them used for all sorts of different things. I've got scans of steam trains and all sorts of other ones. You'll see a nice scan of a lathe in a minute. This allows us to visualize and evaluate solid models in the context of the point clouds. Is it going to fit? Does it look right, etc. Included with Solid Premium, and it's also on the new token licensing, which you may have seen in some of the other sessions on there during the Digital University event. So it supports measurements such as measure distance, minimum distance, angle and inquire. I find inquire very useful because that will give us the X, Y, Z at that point in relation to the coordinate system. So we could note down these values, screenshot into Word, and then go and use 3D sketching key points to go and create these points, and then go and create a surface, which is exactly what I did in the example that we've got coming up. We can also measure point to point within a cloud. So how much room have we got to get this in, for instance, and we can measure the point cloud to a geometry point as well. So let's have a look at this. So if we go into here, so here we've got our point cloud. Okay, so we can go to our density, so we can decide on our density and we can decide the size. So I find 4 or 5 works nice, 6 is a little bit too blocky, and we can also change the actual density of there. So we've got, kind of allows us to kind of zoom in on there. I'm going to set that to maximum. Size 6 doesn't look too bad on there, and then that's our cloud. One great thing that it does, it will actually remember this cloud in the assembly file. So there is an option in the options to say remember point cloud data. So here we've got the part that I've made. And what I'm going to do, I'm going to go and bring this component in. So we're looking at making a new machine guard for this. And if I go and bring this part in, we can see it's actually been made in situ. So now I brought that in, it's kind of matching the coordinate system. So this allows us to see if we go and make this part, are we going to have any issues. If I spin round, we can go and take our little stop plate on the top, but everything else looks like it will kind of sit in nicely, and that will give us a guide to how this new part is going to work, and we shouldn't get any clashing on there. We can see we've got a drawing on the top of there as well during that scan, and we've got enough information to allow us to go, yep, this is going to work, this is not going to work, for instance. Okay, next we're looking at Visual Explode. This is a quick and dynamic way of collapsing and looking at assembly. We've got a couple of different options. We can just drag it, or we can choose something called stepwise. This is going to kind of break up the sub-assemblies and make those get larger or smaller as we go through these on there. A really nice little command just for visualization at the moment. We have asked, can we use it for something else? Very similar to the one that we also get with Accelerator Share, which is a really nice piece of software. If you don't know about that, speak to your account manager and they will arrange a demo for that. So next we're going to look at CAD Direct. So previously, if we had files from NX, SolidWorks, XT, Step, or Parasolid, Step, etc., we'd have to translate it in Solid Edge, and then we'd have to insert it. So what CAD Direct does is gives us a direct link directly from these files into Solid Edge using the internal component infrastructure that we've now got within Solid Edge. So we can do this for SolidWorks, Parasolid, Step. Other ones will be coming in the future, but we'll let you know as and when those come out. This is useful for transferring internal components to other Siemens software, and we can have our mass material properties come through with this at the same time as well. So here we've got a part that we're going to go and create in NX, and we're going to go and create a hole on here. Okay, and now we're going to go into Solid Edge, and we're going to create an assembly, and then we're going to go and use the CAD Direct. So this is in the insert component CAD Direct option dialog box. We can then go and choose our NX part, and that's going to open, and that's going to come in CAD Direct. We're now in Solid Edge, and we're going to go and create a part in place. So we're going to click on this face, and we're going to create a end cap, etc. kind of thing on here, closed flange, etc. So we're going to choose the shape that we want, and we notice we've got our full associativity to the geometry. Let's go and add some dimensions to this. Select our axis of evolution because we're not using a sketch on here. Notice our 260 is linked to our geometry, and then we've got that on there. So let's just go and pop some holes in there as well. And notice we're snapping to that initial geometry on there as well. We can then choose our pattern, choose our direction, make sure our hole count is correct, and then let's just go and add a couple of little finishing features such as a round. So let's close and return back to here. So this is associative back to here, and we're also going to go and add some bolts using our fastener system on here as well. If you've not used the fastener system, really quick way of adding bolts using save settings does make life a lot easier as well, especially if you're adding washers, lock washers, etc. on there as well. So let's go back into NX, and we're going to go and make a change on the size of this hole, and we're going to see how this is going to go and become associative back to our Solid Edge model. So we're going to make a few different changes. Let's go and reduce the radius, change the hole count, etc. on there. Let's go back to Solid Edge. We can now go to these options, and we've got update the CAD Direct geometry. So if that file is called the same, it's going to go and update, and that file is going to update automatically, linked back to that original one as well. So internal component technology, we've seen that there with CAD Direct, but it's also used for file import. We've seen CAD Direct and assembly modeling. So you can see we've got the different options. So when we bring files in, we can choose to create internal components. For CAD Direct, this is the default setting. for step files, etc., we can go and turn this on. This means that we're not going to get a load of part files. All the part files are going to be internal components that are saved within the assembly file itself, which means that managing those files is going to be much easier. We can also use internal components. So for this one, we're going to have a look at opening files with and without the internal component option dialog box on. So for this one, we're opening the drill. We've got a step file, and we open this into an assembly. I'm going to see this is going to go and translate all of those parasolid files. You need to think about, we're doing this, we're translating, but then we're also saving it. Every time it takes a file, it's taking a template, it's creating a file, it's getting a save date, everything is going to be slower. So let's just wait and see this in real time. No sped up on this section. See, the display is reasonably slow as well, but so we can see that, and we've got our non-internal components. You can see it's creating all those parts. Also, if you are using data management, you've got SE lock, which is going to slow stuff down. Not quite an SE lock in Team Center, but it's still the same kind of thing as well on there. So if we go to that one, that's 22 megabytes, but the step file isn't in there. And then if we go and do the same with internal components, so we're going to choose the same file, apart from we're going to do this step file. So we're going to choose a step file, choose the options dialog box, and we're going to choose the create internal components. All the rest of the options are exactly the same. I think those are set to the default settings on there. Open that using the same template as before. This time, translating to parasolid data types is going to be very similar kind of speed, because it's still translating everything. It's going to be slightly faster because it's not creating files for every single version of that. You can probably tell that that was a little bit quicker. And then the display time is going to be pretty much the same because it's the same, but all those files are now internal components. We can see we've got this little folder on here showing that all of these are now directly within the assembly file rather than having their own separate files on the server. If we don't want these to be internal components, we want to publish these, we can right click on there and choose publish internal components. We can also do this from the tools tab as well if we want to kind of select which ones we publish and which ones we don't. So when we go to the internal components, we can see we've just got that single drill file, which overall I don't think that the first one was quite right. Overall it is about 20% smaller. Obviously that one's still got the step file in there, so that's not quite how it should be on there. So that makes managing those files much easier. So other thing that we've got with internal components is internal component modeling. So this is a new environment where we can model internal components in assembly. It allows users to create and edit internal components using multi-body modeling in the assembly. No part files are created unless you choose to go and create those afterwards, as these live within the assembly profile. The workflow that we do for this is very similar to create part in place. So we can see we've got this new assembly, create part in place, choose what kind of file we want, part, sheet metal. This is a brilliant example, is we've got a channel and we want to do multi-body modeling, but we want to do it with different material thicknesses, different material types. We can't do this in traditional material multi-body modeling, it needs to be the same thickness. So what I'm going to do, I'm going to go and create a channel on here with some holes and slots, just to show that we can go and create items using a normal format on here. So let's do a symmetric extent, 120mm wide. Let's go and use the new multi-edge flange on here. Select the 3 edges, means we don't have to draw a sketch like we would have to do in a contour flange. We can see we've got a bit of clash there, so let's do a trim with a small gap on there. So, and that's nice. And then let's go and do a multi-edge flange on the opposite side as well. The command has stayed active to make life a little bit easier. Let's go and make sure those settings are the same. That value is remembered in there. And then we've gone on there. You can do those multi-edge flanges together. I've found it's kind of better if you don't do too many together. It just makes editing easier if you go and break it up just a little bit on there. So I said we're going to do some slots as well. So we've done some safety corners on those, make sure I haven't got some horrible sharp corners. Let's go and create some slots. Going to use our new context menu to go and constrain these up. Just go and pop some quick dimensions in there, and dimension little, make sure those are all linked in the same length. And then we can go and make sure we've got the appropriate slot size. So we'll do 16, double check its arc end on there. And then the other end, we're not going to bother, but now we're going to have a look at going creating a brace on here to kind of stiffen this. So we're doing sheet metal again. We're going to go and do the same material, some 316 stainless steel. I know I've shown it as A4 for fasteners, but so on here, this time we're going to make sure that we're in ordered again on here. I'm going to create a tab. Let's go and do a parallel plane because we want to kind of drag this down from this top face. So what it's doing is creating associativity, but it's associativity within the same part, which is really nice. We haven't got to worry about like linking items because everything is all within that same assembly. So I'm just going to go and spin that model around, make sure we've got those. And then let's go and use a trim command to go and make sure all this is all trimmed up nicely. And I keep that as simple as possible, but this time notice my thickness is going to be 6mm, which is twice as thick as the original material that we've got. Hide the channel. I'm going to put a couple of chamfers on there. Make sure that we're not going to cause any issues on those rounds when we go and place this. Okay, so I'm going to bring the main channel back. And I'm going to close the assembly model in because I just want to go and reuse this brace again. So if I go and drag this brace in, I can just constrain this like it's a normal part. The only thing that's slightly different is if I go and edit it, I won't actually edit this brace, I'll end up editing the other brace. So if I click on that and edit, I would go and start editing the other version on there. We see on properties there's no origination date on the brace or the main channel because they're internal components on there. We can choose the publish if we need to go and create these as their separate components. So it is pretty much multi-body modeling on steroids in the assembly environment, if you understand what I mean by that. Okay, so next we're going to look at the decal tool. Again, I've got a lovely slide here, but the video is much better than here. So view tab, decal, a couple of options, planar projection or label. Depending on which one we go to, we're going to see a slightly different box. So when we do the planar, that's the bottom run on there. So insert image, face step, decal step. If we choose label, that's the top option. Insert image, choose face, choose plane, position it, and then decal display step on there. So once we've chosen insert image, same dialog box for both, choose the image. There's a transparent color option on there as well. And then we can go and decide the position in label, in projection, planar projection or label. We've got these options, the two right hand bottom images kind of thing. We can decide the width, height, offset, etc. Offset, I'll tell you again in a minute, but offset is in meters. So that 1.00 is in meters. So just be aware if you want to move it 20mm, it's 0.020, etc. So let's have a look at this image. So we've got one of my little bottom bracket crank, one of my Shimano tools that I've made in here. So let's go and find a image on here. So let's go and choose a mixer. That's the group that we're part of, and then select the face that we're on there. So first thing I do is go to my decal display step, and then I'm going to flip this horizontally and vertically to get that round. I'm not going to try and do a weird angle or anything. Make sure the aspect ratio is locked, and then go and set that width to the appropriate size on there. Because it's selected the face, you can see it's got the green edges. It's saying, well, this is the face. This decal display step allows us to go through there. If I go up or down, that allows us to go and spin that around. If I go up or down, it's 10 mile high, so it completely does it. It completely removes it if I choose the offset Y. Okay, so what I'm going to do, I want to kind of put this all around the other side. So I'm going to measure the edge, 144.51. So that's 72.25, something along those lines. So I'm just going to go back into the existing decal and choose my edit definition. And I know this is in meters, so as I go and move that, it's going to go move that round. So I need to do 0.07725 to get that roughly where that wants to go. If I spin around, that's actually gone and it's starting to remove it. So if it does that, nice little trick is go and just take that round the other way. So if we just go and add that to a minus, that's going to go and flip that round, and that's then going to work okay. So if ever we do see that option, it's like it only likes to go around the one way if we do go and spin that round on there. Okay, let's have a look at the other option. So this time we're going to do our planar projection, and then we're going to go and choose a image on there. So let's just go and choose a black OnePLM logo on here. I want to go and place that on a planar face. If I place it on a circular face, it's going to project it on and skew it. So I would only really recommend this for our flat faces on here. So let's go and change our width, 20 mm. Let's drag that on, see how that looks. Still a little bit too big. Let's go down a little bit more. That's kind of acceptable. So and then we go and constrain that. As though it's just a rectangle, just think I'm constraining this like this is a rectangle on there. And then finish. And then we've got that image applied on there. Notice that's a different image type, so we haven't got that transparency. Okay, thank you. I was Chris Morgan. James was meant to be doing some of those, but I've just done this video. So we've looked at assembly modeling tools, assembly view tools, compare, assembly visualization, working with important data, definitely more effectively using the internal component stuff, some really useful stuff, and we've done geometry. Thank you very much for listening. I hope to see you on one of my videos again. Thank you.